Alright, in Unit 3, Lesson 5, I've had a question about 7b and Part V, okay, or Part 5. So for this one, we want to use limits finding the tangents. So in order to find a slope of the tangent line, we're going to use the method of the function x plus h minus the original function divided by h. So for the function we're analyzing, everywhere there's an x, we're going to replace it with x plus h. So we end up with the square root of x plus h plus 3, excuse me, minus the original function, x plus 3, that's all over h. Now when we look at this function, we try to make sure everything's one fraction, which it is. Factoring won't work. So in this case, we're going to have to use our conjugate tool. So that means x plus h plus 3 plus root x plus 3. Whatever we do at the top, we do at the bottom. So we're going to multiply by conjugate top and bottom. So that means the limit as h approaches 0. When you multiply those radicals together or distribute it using FOILing, you get x plus h plus 3 minus, and then in brackets, because you are subtracting, again, 90% of error happens right there, over h, and now, unfortunately, we're going to have to write a long mess out here. So I'm going to save myself a step and do a bit of an analysis here. So again, this is a negative that's distributed in. So that means the x's will cancel because that would be a negative x. My 3's will cancel. So I'm left with the limit as h approaches 0 for h over h. X plus h plus 3 plus x plus 3. H's now cancel out. So now I can do an analysis. Do I have a problem still if I substitute h of 0 in? And I find out no. So equals the limit as h approaches 0. Oops, I don't need the limit notation now anymore because I just determined there was no issues. So that means the expression for slope would be 1 over. If the h became a 0, I would have the square root of x plus 3 plus the square root of x plus 3, which means I have 2 of those. So there is my expression for slope right there. There's what the slope is at any point on the curve. So, what is the slope at? The point is 6, 3. So m would equal 1 over 2 square root of my x value, which is 6, plus 3. So I'd have 1 over 2 root 9. Root 9 is just a 3, so I'm going to end up with a slope of 1/6. So that is the slope at the specific point 6, 3. So the equation of tangent line. Tangent line. Again, I prefer y equals m, x minus x1 plus y1. Oops, y1. So y equals 1/6, x minus 6, and the y value was a plus 3. And now I just need to simplify that. So y equals 1/6 x minus 1 plus 3, or 1/6 x plus 2. So that again is the equation of the tangent line. At 6, 3. All right. So it's the same process as we did in the note. We're just finding the limit as x plus h and h approaching 0. So if you have any further questions with that, let me know.